Okay, so today we are looking at lesson 27, which is continuing on with our percent problems. We still have our same setup of equal fractions with the part going over the total and the percent going over 100. In today's problems, we are going to be given the percents, so you may want to flip-flop these two around, putting percent over 100 first, and then putting the part over the total second, just so that you'll be working left to right, because the first fraction will be a completely filled-in fraction. So today's problems are going to kind of step it up a little bit. I'm going to ask that we start taking some notes on the problem on our paper, and that may help us to fill in some of the numbers as we're working. So example 1 says 45% of the students were going to go away for vacation over the spring break. If there were 160 total students, how many were not going away for spring break? So the first thing I'm going to say is that maybe on our paper we should be writing 45% and then saying what it's talking about. So 45% going away. The number in the problem, the 160, is talking about the total students. And then the question is asking how many are not going away. So we've got kind of a lot of information here. We're given the percent going away and the total. But the question is not asking us for the number that are going away. So what's being asked of us is not matching what is given to us. Anytime we are given a total, we can work with the percent to make it match what we're looking for. If 45% are going away, we can find the percent not going away. And the way that we can find this is by taking our total percent, which is always 100, subtracting the 45% that are going away, and what's left over is going to be the percent not going away. So by subtracting our percent from 100, we're able to find the opposite percent. Now we have the percent that's matching what we're looking for. So when we go to set up our problem, we would have the percent not going away, which I'll just put percent not. Percent always goes over 100. Across from percent not going away should be number not going away. Remember, these two things should match each other, or in other words, talk about the same thing. So not going away, not going away. And across from 100 is always our total. So filling in the numbers from the problem, we found the percent not going away by subtracting, and that was 55. I'm going to put that over 100. I'm looking to find the number not going away. So that's the one I don't know in this puzzle. I'm missing that number. And the total was given to me in the problem. That's that 160. So looking at this, I'm going to simplify 55 over 100 to find a number that will work nicely with the 160. You can divide these and you'll just end up getting a decimal, and you can multiply by the decimal on both. You'll get the same answer. It doesn't really matter which way you go about doing it. If I do 55 divided by 5, I get 11, and 100 divided by 5 is 20. So I'm going to rework this problem. Instead of 55 over 100, I'm going to rewrite it as 11 over 20. This time, 20 does go equally into 160. It goes in 8 times. So 20 times 8 is 160. 11 times 8 gives me 88. So that tells me there are 88 not going. So 88 students not going, which is what the question was asking me for. So with this problem, our percent didn't match what we were looking for. We were given a total, so we can just use our idea that 100% minus the percent given is the opposite percent. Let's look at a different example. So example 2 says 35% of Alicia's budget is spent on groceries. If she spends $140 on groceries, how much does she not spend on groceries? So looking at our notes, 35% is on groceries. The number in the problem, 140, is spent on groceries. And the question is asking for not on groceries. So as you can see, our percent matches the number in the problem. So if we were doing our equal fractions, these two would be across from each other. But the question is asking for not groceries. So in this type of problem, we can't change the 140. That's what's stated and given to us. So we're going to work with the percent groceries and the number groceries to find our total. So what that would look like is we have percent groceries over 100, because percents always go over 100. We have the number groceries, because across from percent groceries, I should have number groceries. And then across from 100 is always the total. When I put in my numbers, the 35 is the percent groceries. The 140 is the number groceries. And this is going to give me my total. So notice, that's not what the question is asking, but by finding the total, we can use it and the amount spent on groceries to find the amount not spent on groceries. So when looking at this problem, if I do 140 divided by 35, it will give me 4. So that means to go from 35 to 140, I'm multiplying by 4. Which means to go to from 100 to our total, I'll multiply by 4. So 100 times 4 gives me a total of $400. What that means is she has a total budget of $400. We want to take the total budget and the amount she spends on groceries and subtract the two numbers to figure out how much she does not spend on groceries. So I'm going to take my total minus the 140. So this is my total budget. This is the amount spent on groceries. And what's left over is going to be the amount not spent on groceries. So that would be our answer. So what's different between this example and the first example is that the percent and number given to us do match. We are going to use those two numbers to find our total and then subtract at the end. So in the first problem, we subtracted the percent from 100 in the beginning, and in this problem, we subtracted the total and the amount given at the end. Number 3 is similar to number 1. This one says 60% of the homeworks graded were B or better. If there were 175 homeworks graded, how many were lower than a B? So the 60% is talking about B or better. So I'm just going to put B and up with an arrow just to represent that. The 175 homeworks graded is our total homeworks. The question is asking for less than a B or lower than a B. So I'm just going to put an arrow down and a B. So in this case, we are given a total, which means we can kind of play with our percent a little bit. Since our percent doesn't match what we're looking for, these are opposite things, I can subtract my percent from 100 to get the percent that would match lower than a B. So if I take 100%, which is my total, subtract the 60%, which is a B or better, it's going to tell me how many are left over or lower than a B. In my setup, I would have percent lower than a B over 100 because a percent always goes over 100. If I have percent lower than a B in my numerator, across from it I should have number lower than a B. And across from from 100 is always total. So So plugging in the numbers we know the percent less than a b is 40 from our subtraction. We're looking to find the number less than a b or lower than a b. And our total was given to us in the problem as 175. So what I'm going to do at this point is I am going to divide 175 by 100. And when I do that, it's going to give me a decimal. And that's okay to have a decimal. I just want to show you this type of problem so that you can see what it looks like. So if I do 175 divided by 100, oops, I think I did 1,000. 175 divided by 100, it's going to give me 1.75. So what that means is if I do 100 times 1.75, it's giving me 175. Since this is a nice decimal, and by nice decimal, I mean it doesn't go on and on forever and ever and ever, it doesn't repeat, I can use it. So if you get a nice decimal, it only goes 1, 2, or 3 digits past the decimal, I would say you can go ahead and use it as a decimal. Otherwise, you would want to simplify the fraction to try and get a number that goes in equally. So this is just one way I'm just showing you that you can do it with the decimal if the decimal is nice. So I'm going to take my 1.75 and multiply it by 40, which gives me 70. So that means 70 students got less than a B. So our answer would be 70 students with less than a B. Now, the next example is going to really step up our difficulty level. So if we look at example 4, it says 20% of the students on team 6-1 wear glasses. If there are 88 students that do not wear glasses, how many students do wear glasses? So let's break it down in our notes. We've got 20% wearing glasses, and I'm just going to abbreviate glasses with GL. We've got 88 not wearing glasses, so I'm just going to put not GL for not glasses. And the question is asking us how many do wear glasses. So in this problem, our percent does not match the number given to us. The percent is talking about how many do wear glasses. The number is talking about how many do not wear glasses. In this case, if I were to have a total given to me, I would be able to work with it no problem. But because I'm not given a total, I have to work with the percent that I'm given. So 88 is how many do not wear glasses, which means I can't change that number. I can't change this number to match my percent. I don't have anything to work with beyond the 88 to change it to match the 20%. However, I do have something I can do with the 20% to make it match the 88 or the not glasses. So what I have to do in this case is turn the percent into the percent not wearing glasses. So I would take 100% total, subtract the 20% that wear glasses, and get 80% that do not wear glasses. Okay, so I am now going to set up my equal fractions. I would have percent not glasses over 100. If I have percent not glasses in my numerator, across from it I should have number not glasses. And across from 100 is always the total. So plugging in the numbers I know, 80% is not glasses as we found from subtracting. The number not glasses from the problem is 88. And this is going to give me my total. Notice we're not looking to find the total from the problem. We're looking to find the number that wear glasses. So this should tell us we're going to have to do another subtraction problem at the end. So this is where the challenge level really steps up. We have the subtraction of the percents in the beginning, and then we're going to have a subtraction at the end of the problem as well. So to find our total, I know 8 doesn't go into 88 equally, but I can see if I take a 0 for 0 or divide both numbers by 10, 8 does go into 88 equally. 8 times 11 is 88, so I would do 10 times 11 to get my total of 110. If I know the total number of students, and I know the number not wearing glasses, I can subtract those two numbers to find the number of students that are wearing glasses, which is what the problem was asking me to find. Okay, so in this one, it's a double subtraction problem. Our percent did not match the number given to us. The number given to us was not a total. So when that happens, it's a double subtraction problem. You must start by subtracting the percent from 100 to get the percent that matches that number. Then you use that information in equal fractions to find your total. And then you have to subtract once again your total and the part given, in this case the number not wearing glasses, to find the number that you're looking for. So again, some of these problems are somewhat similar just based on the percent piece instead of the part and total piece like we've done in the past. But number 4 example really steps it up. So I would highly recommend taking these notes off to the side to see what information you're given and then seeing where you need to go from there. Please let me know if you have any questions.